Welcome back to our introduction number 3, tutorial number 3, and now we are continuing to speak about classes in R, the elements that we are gonna be working with, and the moment comes to talk about vector, matrices, lists, and data frames, which are very important in R and the K elements almost every time we work. Okay, so let's begin with vectors. Vectors are a collection. Vectors are collections of things when the things are the same kind of. So that means it can be a collection of numbers, can be a collection of factors, can be a collection of characters, it can be a collection of logical values, but it's not allowed for a vector to have, like, say, 2 characters, 3 numbers, and 4 dates, for example. Okay, so vectors are collections of the same thing. Okay, a way to define a vector is with the concatenate operation. So let's do one factor. For example, I concatenate numbers 3, 6, 78, 99, 0, and 2. So that is saying that x now it is a vector which contains all these values. Show me x, control enter. X is 3, 6, 78, 99, 0, or 2. Okay? I can see which is the class of x. The class of x, now it's numeric because it contains only numbers, so it's not saying to me that the class of x is a vector, it's saying to me which kind of elements it has inside. Okay, let's say that I make x now, x are letters as we saw, which is from 1 to 10, and now show me x. So now I have all these values. Let's see which is the class of x. Class of x is character, okay, because I have all these values as a character. Let's make another one. Factor. Transform the previous one, which is a character vector, transform it into a factor vector. So I am applying the same function as that I was applying to an atomic character or an atomic value, but now I apply it over a vector. So this function is gonna go inside each element and do the operation. So, but knowing all of it as a vector. So now I apply this function, and after show it to me. So I have now factorized this x, and the result is that now the values are the same as before, like a, b, c, d, e, when it was a character, but now it's not a character, now it's a factor with these levels. Okay, so let's erase that because we did it. This also. This is another one, for example, a few strings together, class of x, it's also a character. Now let's talk about how to access vectors. So how can we get inside to see which is the element number 1, which is the first, which is the last one, which is... So this is very important in R, we are going to use it so much. So now if I go to the first, if I want to see which is the first value of it, I take these special brackets here and I say the element number 1. This is gonna be control enter, this is gonna be element number 1, we. Okay, because this was our vector. Element number 2 is gonna be this one, SDS. Element number 10, there is no assigned value because there is nothing there. Okay, so NA it's a special value in R. We didn't speak, I think perhaps we did or perhaps we did not, but to comment a line as I'm doing here, it's with this symbol, and then all the rest of the line is gonna be a comment. Okay, very useful to. If you are working in Windows also, you can divide sections by doing or with Macintosh with more advanced R Studio than I have. When you put together 4 of these characters, there is some arrow here coming here and makes you that you can fold this part until the next one, and it gets very useful to put different sections, as we could do like this. Okay, so that's why I'm doing. Each time we do something else, for something new, I am adding this 4 here. It doesn't work with this RStudio because it's for 32 bits and it's kind of an old one, but it works with the new ones. Okay, so let's see. So this was giving NA, which is non-assigned value, which is also very important. You will see. We will talk about that later on. Okay, now if I want to access two different values or elements in my vector, for example, so then I will concatenate the positions of them. I want number 1 and number 3 only. Sorry. So then I will have these two, number 1 and number 3 together. Okay. Another way to do that, which is equivalent, is equivalent in the processing. From 1 to 2, only the first 2, because you will see that this operation of putting this one, for example, if I do that, that gives me a vector that goes from 1 to 10. You can see here down. If I do from 1 to 100, I'm going to have all these values. Okay, so when I do this from 1 to 2, it gives me the element number 1 through the element number 2. I can reorder a vector if I change the indexes of it. So say that the indexes of this vector is going to be 3, 2, and 1. Yeah, and I want to reorder the vector with these indexes. So I make that, I apply that, and I now I go and I say, okay, so now show me this one, but with these indexes. So element number 3, element number 2, element number 1, and I will have the result down there. So this is a way to reorder vectors, and we're gonna use it a lot. It's really very useful, and so taking indexes and reordering. I could do that also, like from 3 to 1, and say show me the indexes. You see 3 to 1, and now this is gonna be different. Okay, so now named vectors. Named vectors means that I can also say for each one of the elements which is the name of it. This is gonna be very used in data frames where we have data like birth date, diagnosis, region. Okay, so if I apply that and I show it, you will see that now instead of showing me only the numbers, the result, it shows me also the names of each one of them. Okay. When I have a named vector, I can access the named vector in this way. So let's do it in real time. I want to access the element which is called x1, and then I have the result is number 1. Is 3 would be 3. Let's see which are the attributes of x. We saw that attributes means that kind of the internal structure and what its characteristics, okay, inside R. So attributes of X, its names only. So we can perhaps change the names of them. So how they are called, instead of, for example, x1, x2, x3, I call them y1, y2, y3. So I assign that, which is a concatenated vector this time, to the names of x. So then I apply, and now show me that, and now we can see that the names have changed from x1 to that. Okay. Very useful command, as we saw earlier, was structure of X. So it says to us that the structure of X, it's a named numerical vector which goes from 1 to 3, and these are the values, and it has an attribute called names, which is a character vector that goes to 1 to 3, so 3 elements, and this is the values of them. So structure is always a good way to find out what is the characteristics of element in R. Another way to access vectors, parts of vectors, is to go to Boolean vector indexes. What does it mean? That it means a collection of true, false, false, true, false, false, true, for example. So let's say that we want to have the index a vector of results of this operation. It's equal to 1. So when is x equal to 1? So if we do that, x equal to 1, we will have a vector because it's taking the first element of x and saying, is that equal to 1? Yes or no? Second element of x, is this equal to 1? Yes or no? Third element of x is equal to 1? Yes or no? So this is very common in R and is used all the time, that an operation made for a vector makes it for all the elements of it. Okay? Then sometimes, but it's usually like that. So we will see more of that in detail when it's happening that or not, but in this case it's doing it for every element, and then we have the result of b.x. This is a variable which is containing the result of this operation, which is in this case is true, false, false, because only the first element of x is equal to 1. So now we can index the vector x with this vector, and it's gonna give only the result will be only the ones which are true. So in this case it's gonna take only the first element of that vector, as you can see here. So in this case we take only the element where that was true. Okay, so this is a way to subset. Okay, let's do another thing, greater or equal to 2, for example. So we apply that, and now the result of applying this Boolean vector is 2 and 3, because 2 and 3 are greater or equal to 2. Another way to subset is using which. Which is a command that gives the indexes where the expression is true, so it's the same. So the indexes where which x equal to 1, which are that? So let me show idx, which is the index, so it's only 1. So if I go to x of only 1, I will get the first. Okay. If I take now like x to be a vector that goes from 1 to 100, so it contains 100 elements from 1 to 100, one after the other, I can make a more complex index, which is gonna be which which indexes are true, which values of which element of x make this true, that the square of it is greater than 100, and when I add number 2, it's lower or equal to 20. Okay, so this is the result of the indexes of that. So I see here down that is element number 11, element number 12, element number 13, element number 14, etc. So if I apply that to x, I will get the same things because they are the same. But let me begin with another one, which is going to be better to understand. So now if I begin with this 1000 to 1100, let's do it with, let's begin with 3 and go to 103. Okay, like this we have differences in indexes, and so then I do the same. The indexes are 9, 10, 11, 12, and when I apply x to these elements, it gives me 11, 12, 13, 14. Okay, so this is the result, and these are the indexes when the expression was true. Okay, so this using which a condition, and after making this subsetting with the indexes, is gonna be extremely common in our operation. It's very fast, it's very effective, it's not using a lot of memory, so it's one of the, and it's very clear what we are doing. So it's one of the best way to subset vectors. Okay, operations of vectors. Let's go to how do we generate vectors. So a way to generate vectors is, as we did already, is to assign a sequence of numbers that goes from the first one, for example number 23, to the last one, 55. So you will see, if we do that, we have from 23 to 55, okay, one after the other. This is a way to do it. Another way to do it is to sample things. Very useful to generate data. Sample, that means that to take from one set of values, to take them and reorder them or put them again and again and again from that previous set. So if I have, for example, my values that go from 1 to 5, I want a vector which has the size of 20. So there is 20 elements, but it's only going to contain values from 1 to 5. So I need to say replace true equal to true, or I can make it shorter if I only put this t. That means replace equal to true means that if my collection of numbers, like in this case 1 to 5, is shorter than my bigger one, I'm gonna take again, replace these void elements with elements from the first set. So I need to put replace equal to true each time my final vector is bigger in elements than my collection of sampling, which is from the, in this case I have 5 elements here, and I will have 20 elements at the end, so I need to put replace true. So if I do that, let's see the result of it. So you see I have a collection of numbers, a vector of numbers that go, the values go to from 1 to 5, and I have 20. So it's a random generation of a set. If I want only to reorder a vector, I will do it like that. Only to reorder from 1 to 5. So I have the result here, 3, 1, 2, 4, 5. If I do it again, 3, 4, 2, 1, 5. It's a random process, so each time I do it, it's gonna be a different thing. Okay. Another way to generate, which can be very useful, is the repeat. Repeat. So repeat what? Repeat this string 10 times and show it to me. So this is repeating. I can do it also with numbers, like repeat 0 10 times. I can do it a little bit more complicated. Repeat from 0 to 2 10 times. So I have 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 10 times. Or I can repeat ten times. 1, hello, 1, hello, 1, hello, 10 times. Okay? So another way to generate vectors is the sequence. So the sequence says from where, which is the first value, which is going to be the last value, and which is the difference between each element, so by 3. Okay, so let's apply that, and it's 12, 15, 18, 21, 24, 27, etc. Okay, sometimes we need to generate this kind of vectors, C1, C2, C3, C4, C5, for example. So let's see how we can do that. We would say X, it's the result of what? So let's so it's gonna be past. Why? Paste. Why paste? Because we are gonna concatenate two things which are gonna be strings, because C was a, so paste C with what? With 1 to 5, with the vector 1 to 5. And the separation I want to be nothing, so I put only this, nothing inside the quotes. So if I do that, I will have this vector of values, C1, C2, C3, C4, C5. Okay, if I change that, for example, for var, I will have variable 1, variable 2, variable 3. That can be useful for columns or for different things, like diagnose. Okay, diagnose 1, diagnose 2, diagnose 3, diagnose 4, diagnose 5. Okay, so I can generate also like that. Okay, so which kind of mathematics can we do with vectors? So say that x it's from 4 to 10, and y is from 12 to 18. So I can do this kind of mathematics, x plus y, and you see I am adding together the elements one by one. So 4 plus 12 is going to be 16, etc. If I do also an operation like this, I am also making element by element the operation. I can also divide, and I have also this 4 divided in 12, 0.3, etc. So it's element by element. I also can apply a function over the elements of a z if I put this. So I don't have to do it for each element, I only do it for that. I can do also, so this is rounding the value with this number of digits. I apply that over a vector. Sum of all the elements of the vector, which is the length of the vector, 7 elements, which is the mean, which is the summary. Summary is it's calculating some statistics over it, the minimum, the first quantile, the median, the mean, the third quantile, and the maximum. I can add one single number, and it's gonna be adding to each element of this, 14, 15, 17, and now it's this what comes now, it's very important to understand. It's called recycling. So that means that if X has more elements than the other member, I'm gonna take it again and again. So X has 7 elements, but this one has only 2. So when I do this operation, I will take, for the first 2 values, it's gonna take these 2 ones, but for the third and the fourth, it's gonna take also these 2 ones, etc. So it's gonna recycle. Yeah, it cannot recycle if the length, you see here, there is a warning here. So if I want really to recycle it well, I should have that X, it's a multiple of the other one, of 2. So, and like this I don't have the warning, so because here I have 7 elements, but if I do it now, that comes to 11. So X from 4 to 11. Now I'm gonna recycle it a number of times, so that is gonna be, I will have the same. So okay, now I do that and apply to X this one. Okay, so recycling is kind of important thing to understand. Perhaps we don't use it a lot, but it can be good to know that. Okay, so now how can I change vectors? How can I change that? So I can change vectors in multiple ways. We saw that we can do operations over them, and we can also change the class. So I can make that this vector is as a character vector. So now instead of being numbers, it is strings. If I now say structure of it, it's yeah, that was because, but if I say X, I apply the result of X to X. So now it's character that goes from 1 to 8, 4, 5, 6, 6. I also can change it as factor. And we can see the structure of it. Instead of being a character, now it's a factor that has 8 levels, 10, 11, 4, and they are ordered this way. Okay, so this is how to change classes, and it can be important to, I also can do this, apply as numeric. Okay, 3, 4, 1, 6, 7, 8, 1, 2, because these were the levels of the factors. Okay, so this is the end of this part about vectors. We are gonna split these vector matrices and list data frame in different videos, because if we don't do that, it's gonna be too long. And but it was kind of an important lesson, I think. And see you in the next one.